quantitative technique for business. Today we'll be dealing with Spearman's rank correlation, which is again a part of coefficient of correlation. See, correlation, we have completed what is correlation, what are the different types in which we could calculate correlation. From that, we have taken graphical method as well as algebraic method. From algebraic method, we have covered what is called Pearson's correlation coefficient. And now we are into Spearman's rank correlation coefficient, which is commonly known as rho. Okay, so what happens here? This is one of the kind of correlation wherein non-para which we could call as non-parametric, right? Now, why it is non-parametric? Because we know that Carl Pearson's coefficient of correlation is used to measure correlation between variables which are normally distributed. But if population is not normal, or the shape of distribution is not known, what we can do for calculating correlation? That is where Spearman's rank correlation come into our rescue. So what is Spearman's rank correlation? What we do is we convert the data into ranks, and we'll see whether this ranks is having any correlation between them. So if you see, the value of rho is always between -1 and +1, which is same as that of our Carl Pearson's correlation coefficient. Then next property says that if the relationship between x and y is positive, then rho will be positive. So this is very important point which you could expect as an NET exam question also. Okay, if the relationship between x and y is negative, the rho will be negative. If there is no relationship between x and y, the rho, which is rank correlation coefficient, will be 0. The value of rho will be +1 if ranks of x completely agrees with rank of y. Means the value which x is having and the rank which x have got will be completely in agreement with y, right? Suppose there is increase, or maybe the value of x increases from 10 to 100, and maybe value of y increases from 20 to 200, right? So you could see that there is a change, right? There is a change which is positively to in case of x as well as in case of y, and that will be reflected in ranks of x and ranks of y, right? So if you take the relationship between rank of x and rank of y, we could see there is very close relationship between them. Okay, so the last point, the value of rho will be -1 if the ranks of x are in reverse order of rank of y, in the way that if rank of x is moving towards one direction and rank of y is moving just opposite of it, what will happen? We'll have a negative correlation. Okay, so putting all these things together, we could say that Carl Pearson's coefficient was something which is related to parametric, or maybe which is related to variable which is normally distributed, and Spearman's rank correlation is a distribution free correlation. Moreover, Spearman's rank correlation can be used to measure correlation which is qualitative in nature. So to study the correlation between attributes which is not which is very hard to measure by quantity. Say for example, if you take IQ level of somebody, if you take judgment done for some qualitative work, if you take the management ability, all these things, it is very hard to quantify them. So if there is a variable which is related to such things, we could use instead of Carl Pearson's correlation coefficient, we could easily use Spearman's rank correlation. Spearman's rank correlation was invented in or put forward for the first time in 1904, right? And it was done by Charles Edward Spearman. Charles Edward Spearman. Charles, Charles, Charles Edward Spearman, and this method is named after him. Let us move on. So Spearman's rank correlation coefficient is defined as follow. Then um, how it is defined? Rho is equal to 1 minus 6 into sigma d square divided by n into n square minus 1, which can be written as 1 minus 6 sigma d square divided by n cube minus n. Okay, now what is n? N obviously will be number of pairs which is compared, right? It can be x or y, whatever it is. It is a number of pairs which is compared. D denotes the difference between the ranks. Difference between ranks. And R, obviously it is row. Okay, so we'll go for an example and see what exactly it is. Now, before going for that, there is a very important note which I would like to give you, which is I've put in red letters. Spearman's R is less sensitive to extreme observations, right? So, what makes Spearman's rank correlation more, say what makes it different from that of rank correlation? Carl Pearson's coefficient of correlation. The only thing is that Carl Pearson's correlation coefficient is sensitive of extreme values, or we could say it as outliers, extreme values or outliers. So if there is a presence of outlier or a value which is outside, say the normal course, it is going to affect the Carl Pearson's correlation coefficient. But such type of effect is not there in case of Spearman's rank correlation. So this is a point which you could score and which is quite rarely discussed. Okay, so let us go into the first example what we have. From the following data, calculate rank correlation coefficient. We have values of A and values of B given 60, 34, 40, 50, 45, likewise till 46, and the value of B's are from 75 to 57. So what we are going to do, first foremost step is to give rank for them, right? So first step is assign rank, right? So how we will assign rank? We are going to assign rank by taking, you could do it in any way, but normally what we are doing here at us, we will be giving highest value the first rank, right, and the lowest value the least rank. Okay, so we could do it in vice versa also. We could take the lowest value first rank and the highest value last rank, right? So in this case, 66 values of, if you look at the values of A, 66 have got is the highest, and will give rank 1 here. So what I'm going to do is I'm going to transfer this into a table which look like this, and I'm going to write what are the ranks, right? So this will be first rank in case of A, then second will be 64, then third will be 60, and fourth will be 50, fifth will be 46, sixth will be 45, seventh will be 43, eighth will be 42, then ninth it will be 41, 10th it is 40, 11th it is 34, and 12th it is 22. Since there is no repetition coming in, it was quite easy for us to give ranks. Okay, so similarly we will be also giving rank to the values of B. We will start from the highest value, which is 75, and we will give 1 here. Then we will give 2 to 72, then 3 to 57, 4 will be 45, 5 will be 41, 6 will be 40, 7 will be 36, isn't it? 8 will be 34, 9 will be 33, 10 will be is 32, and I am missing that 32 here. I'm sorry for that. this is 32 actually. It was not 35, this is 32. So if you look at the previous, if you look at this question, it was 32 here. It was 32, but unfortunately, when I wrote it here, I wrote it as 35. Okay, leave it. So our next, our 10th rank will be given to 32. Then 13, which is rank 11. Then last one, 12th rank it is for 12. Okay, now the second thing is that second step, first step was to give a rank for all the values. What we have done, we have given first rank for the highest value and last rank for the least or lowest value. Okay, now we are supposed to take the difference, right? Difference of ranks and square it, right? For example, we are supposed to take difference of rank for the first case, right? First case, it is 3 and 1, right? Am I right? So 3 minus 1 square, which is 2 square, which is equal to 4. Am I right? Then here you could see with the difference between first 11 and 10, it is 1, and 1 square, it is 1 itself, right? Then here it is 2, 2 square, the difference is 2, 2 square, it will be 4. Likewise, here also we will have 2 and the square is 4. Here also 2, the square is 4. Now see what is it, what is the difference between 9 and 9. In both cases we are having 9, and since the difference is 0, we are not concerned about what happens there. So here also 12 and 12, it is same. 12 minus 12, it is 0. 7 minus 11, it is actually negative 4, and negative 4 square will be 16. Likewise, the next one, it will be 1. Here also it is 1. 3, 2 minus 5, it is 3. Negative 3 square, it is 9. And last one, it is 2, and the 2 square, it is 4. So we need what? We need sigma d square, which is sum of all these values, sum of the differences which is squared, right? So square differences. So our sigma d square will be what? The sum of all these values, which is 48. Now it was very simple. We need to get what? We need to get the formulae. Just substitute all the values, then get what is Spearman's rank correlation, right? So we know what is the formula for calculating Spearman's rank correlation. It is R equal to 1 minus 6 sigma d square divided by n cube minus n, which is 1 minus 6 into 48 divided by n. Here stands for number of items, right, or number of pairs, which is 10, right? So this will be 10 cube minus 10, which gives us the value 1 minus 0.1678. 0.1678. Our final answer will be 0.83. So we could conclude that there is a very strong positive correlation between A and B. Okay, now this is okay, but if we are having some values which is repeating, if you look at the values which is given, or if you take A or B, there was no value which was repeating. Am I right? If a repeating or repetition comes in, what will happen? We will have to make a slight change in our formula and a slight change in calculation, which will help us to understand how we could do it. Okay, so for that I am taking another example. So before going for that, this is the formula. The slight change, if you look at these, there is a slight change, which is 1 by 12. There is an addition, right? So r, if equal ranks appears, r equal to 1 minus 6 into sigma d square plus 1 by 12 into m cube minus m. M here stands for number of repetition, right? Suppose a value repeat 2 times, m will be 2, not the value. Suppose there is a value which is 10 and 10 repeats 3 times. It is not, m is not 3, or sorry, m is not 10. Instead, we'll look into how many times it has repeated, and that is 3. So we should get m cube minus m, which is 3 cube minus 3. Okay, so this is how we are going to solve this. So we will look each time a value is repeated, we will have to calculate m cube minus m and divide it with 12 and get the sum of all such things which we use in our formula. So we could expand it and write it in this way. Suppose we have two different values repeated, uh, so our calculation can be sigma d square plus 1 divided by 12 into m cube minus m for the first case, plus 1 divided by 12 into m cube minus m for the second, and it may keep go on till we have completed with the number of repetition divided by n cube minus n. There is no other changes. Okay, so now we will see an example which is having such a repetition. So calculate Spearman's rank correlation coefficient from the following data. X values are given: 480, 330, 400, 90, 160, 160, 150, sorry 650. So you could see values repeated. 160 is repeated two times, and 650, 160, sorry 160 is repeated actually three times. Okay, then 570. Here also 130, 130, 240. Likewise we have 190 till now 190. Okay, so what we are going to do, we are again going to give rank for the given values. Okay, so we will give first rank for which type of value. Again we will be following the highest to lowest, where we will be giving the first rank for the very highest value, or the highest value, which is 650 in this case. Okay, so 2 will be what 2 will be very next best value, which is 570, and 3 will be uh, 480. Am I right? 480. Then 4 will be 400. 5 will be given to 330. 6 will be given to 240. Okay, now 7, next biggest value, or next value which we have to rank is 160. So we could see 160 here, 160 here, and 160. So actually their ranks should have been 7, 8, and 9. So how to rank them? The first thing is to know how to rank them. To rank them, we will just give average rank out of this. Average rank in a sense, 7 plus 8 plus 9 divided by 3, which will give us a value of 8. So we'll be assigning 8 for all these three values, 8, 8, and 8. Now I said we need to get m cube minus m, right? So we know that 160 is repeated 3 times. So m cube minus m will be what? M cube minus 1, it will be 3 cube minus 3. So we have to calculate that also. Okay, so m is 3 in this case. Just remember that m is 3, we are not taking the numbers, we are taking the number of time a particular rank or a particular value is repeated. Okay, so since we have given 7, 8, and 9, and we are given the average value for 160, what is left? Again we are left, we don't have 7, we don't have 8, and we don't have 9. Now we have to give 10 for the last value. So the rank of 90 will be 10. Likewise we will be ranking the values of y, wherein we'll give average rank for those values which is repeated. We'll see which is the highest value, which the highest value is 240, so we'll be giving 1 here. Then we have 200, which we will rank as 2. Then we have 190, which will rank as 3. Okay, now 4 is 150 is there, which is 4. Now yes, next values are 130, 130, right? So 130 is repeated how many times? 2 times. Am I right? 130 is repeated 2 times. So m cube minus m will be 2 cube minus q 2 in this case. Okay, let it be that. So 130 is repeated 2 times. So first thing is we have to give average rank. So how can we give average rank? The next ranks are like 5 and 6, right? So we'll give average of 5 and 6, which is 5 plus 6 divided by 2. which will be 5.5. Okay, so this is 5.5 and this is also ranked 5.5. Okay, so 5 and 6 is over. Now we have to give 7 and 90 will get rank 7. 8, what will happen to 8? Now again, there's two values which is again repeated. 60 is again repeated two times. So how can we give average ranks for them? Next ranks are 8 and 9. So 8 plus 9 divided by 2. Here also 8 plus 9 divided by 2 will give us a value which is 8.5. So here also we have to give 8.5. 8.5 and 8.5. And last value which is 40 will be ranked 10. Now this is how we rank when we have more repeated values coming in. So if you look at this entire question, we have 160 repeated 3 times, 130 being repeated 2 times, then we had 60 repeated 2 times. Am I right? 60 repeated 2 times, right? Am I right? So here also 2 cubed minus 2. Now we'll see what is d and d square, right? D square. So if you take now the process is quite simple and quite as normal as what we have done in the earlier case, right? So 5.5 3 minus 5.5, which obviously is 2.5. So d square will be 6.25, right? Here it is 0.5 and d square will be 0.25. And in this case 4 minus 1 it is 3 and 3 squared is 9. 2.25. 4 minus 8 minus 4 it is 4 and obviously it is 16. 8 minus 10 it is negative 2, it is square is 4, right? Negative 2 square. Here it is 4 square. Okay, so different square, that is it. 1 square it is 1, then again 1 square it is 1, 0.5 square it is 0.25, and last one 1 square it is again 1, which will give us a sigma d square of 41. Okay, so we have now sigma d square 41. Then we have some repetitions of 160. 160 is repeated 3 times, 130 is repeated 2 times, and 60 is repeated 2 times. Now we will see how we could substitute these values in rank correlation coefficient or the formulae and see how we'll get it. Okay, so we know that the formula for calculating rank correlation is R equal to, when we have repetition, it is R equal to 1 minus 6 into sigma d square plus 1 divided by 12 into m cube minus m, right? In this case we have 3 repetitions, so we'll have 3 different m cube minus m's, right? So 1 divided by 12 into m cube minus m plus one more, right? M cube minus m whole divided by n cube minus n. Now so what are the values here? 1 minus 6 into sigma d square, we got it as 41. Sigma d square it is 41 plus 1 by 12 into the first repetition of 160 was for 3 times, right? So here it will be 3 cube minus 3 plus 1 by 12 into the second one was repetition of 130 and it repeated 2 times, and m will be value of the number of repetition, which is 2. Here it will be 2 cube minus 2 plus 1 divided by 12 into, again 60 repeated 2 times, so we will be taking 2 cube minus 2. Okay, close the bracket, divided by n cube minus n, where n being the number of pairs, which is 10, so the value will be 10 cube minus 10. So that is 1 minus Solving this, we'll get a simplified form of 1 minus 6 into 41 plus 1 by 12 into 24 plus 1 by 12 into 6 plus 1 by 12 into again 6 divided by 990. So which is again 1 minus 6 into 41 plus 2 plus 0.05 plus 0.05 divided by 990, which will again give us 1 minus 0.267, which is 0.733. So this is how we calculate rank correlation if you have repeated values coming in or repeated ranks coming in. Okay, remember, we have to take m as the number of times a particular value is repeated or number of times a rank is repeated, not the value of rank or value of the x or y which is given. Okay, so with that we are completing rank correlation. Thank you. Have a nice day.